So we are live now. Hello, everyone. Good morning, good afternoon, or good evening, depending on your time zone. Great to have you in our YouTube stream today, and we continue the SAP Cloud Lifecycle Management webcast series. Today, we will talk about the database migration option of the Software Update Manager. It is an important feature of the migration to the SAP HANA database. Our expert speaker for today is Boris Rubart, who is Product Manager at Cloud and Lifecycle Management team at SAP. My name is Larissa Brinkman from the SAP Global User Groups organization, and I'm your host for today. We kindly ask you to place your questions in the live chat, and we will answer them at the end of the presentation. The replay of this session will be available under the same link immediately after the session. With this, I wish you great interaction and kindly ask Boris to take over.
Thank you very much, Larissa, and welcome from my side as well. As mentioned, my name is Boris. I work as a product manager for the Software Update Manager and on conversion topics. So today's topic is Software Update Manager, migration overview and tuning. So we start with a disclaimer. It could be that I mention things, features, aspects that are not yet generally available. So that's why we have the usual disclaimer. Do not take those statements as a reason to obtain a license. This session is one of several sessions that are offered here for the knowledge transfer to SAP user groups. We call this SAP CLM Webcast series. And I've listed those that are in the context of software logistics, in the context of the Software Update Manager. We have started already with Software Update Manager overview. My assumption is you know what the tool is for this session, that we have now migration overview and tuning. There are other sessions. You see the dates listed here. You will have to check the link provided here, as the dates may still change. And this is only an extract of all the sessions that we have in the Cloud and Lifecycle Management area. With this, let us come to the agenda of today's session. 3 sections. We start with the question what the migration option of the Software Update Manager is, for which kind of systems we use this. We will then focus on the question, how does it work? How do I start this option? And then the question on tuning and optimizing the downtime. So let us start. You see here the abbreviation DMO. That is for database migration option. That's a feature of the Software Update Manager to execute a database migration of an existing SAP system. And we will gonna introduce this now. We start with a comparison. What we already have since years is the so-called classical migration. So that's the scenario of a heterogeneous system copy provided by the tool Software Provisioning Manager. This one is out there since a while. It has some advantages and disadvantages. For example, it requires manual decision on which tables to split to reduce the downtime. And to use this tool on productive systems requires a certified consultant. The classical migration provided by the Software Provisioning Manager allows to migrate Java-based systems as well to HANA database. In contrast, we have the database migration option, the inbuilt migration capability of the Software Update Manager. So the tool, the Software Update Manager, can offer a combined approach to migrate the database of the system and update the SAP software of the system. We have created since a while here a blog post that compares the 2 approaches, and the general recommendation is, if possible, use database migration option. And we're going to focus on that one here. DMO, database migration option in a nutshell, it's a use case of the Software Update Manager. It is offered for ABAP-based systems only. The tool as such, SAM 1.1, for example, can handle scenarios for both ABAP or Java-based systems, but a database migration option is offered for ABAP-based systems only for both these two versions that we currently offer for systems. The database migration as such is migrating a system to a different database type. That means it's a heterogeneous migration. We do not support homogeneous migration from MaxDB to MaxDB, for example. That's important. And we call this an in-place procedure. From the perspective of the application server level, this one is kept. We switch the database host. So before starting the tool, you have to provide the target database with the installed database on the host. But the primary application server host is kept in the default scenario. And when we started with this combined software update and database migration, we only supported as a target database SAP HANA database. Meanwhile, there are additional targets possible. All of them are listed in the respective SAP node on database migration option. At the end of the presentation, you will see where to find those nodes and what the current numbers are for those nodes. So currently, we, per default, the Zoom UI offers HANA database and SAP ASE as a valid target. Concerning system conversion, which is a different scenario, combined database migration. System conversion means target is SAP S/4HANA is always running on HANA database. So in case the source ERP system is not yet running on HANA database, of course, the software update manager will not only execute the conversion to SAP S/4HANA, but also carry out, it will execute the database migration. That's clear. That is DMO in a nutshell. We have a kind of comparison. If you compare the software provisioning manager with a classical migration, that was from the early days when there were systems on a lower enhancement package and you wanted to run them on HANA database. There we had the minimum requirement of enhancement package 7. So using the classical way would be to first use the software update manager to update or upgrade the SAP software, maybe also do Unicode conversion, and afterwards doing the migration with a different tool. And now that is the classical way, but it became simplified by introducing several years ago the migration option in the software update manager. You see it combines the upgrade with the database migration, and for specific scenarios, you see the small print here for targets below 750, the tool can even take over the Unicode conversion part. Actually, that is only offered for SAM 1.1, but not for SAM 2.0. So that's the illustration. What kind of benefits does this approach offer? The combined update and migration. Well, we just have one maintenance phase. We have just one downtime instead of two separate events. And that means less regression tests, for example. Then we have the in-place migration procedure that keeps the application server stable and the system ID. That means that has lower impact on the landscape concerning adaptation of interfaces. For example, it's only the database server is new on which the, for example, HANA database is located. Now, we do have two databases, the source database and the target database. The source database is nearly not touched at all. That means we have this original database as an easy fallback solution during the procedure. So if you execute a test and you think, well, I would like to start over, it's very easy. You press the reset button in the menu, and then it will all be restored. And you can use this functionality throughout the complete procedure, and that's an advantage as a fallback solution. Of course, we recommend to create backups at specific points in time. Nevertheless, that reset works even without a backup. Now, again, comparing the two approaches, both the software provisioning manager as well as the software update manager, they use a kernel tool called R3 load. And the R3 load now for the software update manager is using what we call the pipe mode. That's an advantage. So we have R3 load pairs for export and import, both running on the same application server, and they can directly exchange the data. That means we have no need to create large dump files like in the classical migration option. Finishing up is the tool as such. The software update manager has its own logic to calculate which tables to split to optimize and to reduce the downtime. So it's a smart algorithm that works out of the box here. And so it's not required to manually decide which tables to split, which is the case for the classical migration. A rough overview about the process steps is shown in this illustration. You see the application server, the SAP system is starting, well, it's running on the source database. We have the HANA database ready already provided. We start the software update manager with the specific phases, the roadmap steps, upgrade, prepare, execute here. That means there are some preparations done on the target HANA database, setup of the schema, for example. And then once we enter the downtime, that means that the system is switched. It's not available for end users, but in the downtime, the migration of the application data will happen from the source database to the target database, and the upgrade as such is executed on the system. And then afterwards, the system is up again, running on the target HANA database. The note here says the source database as such continues to run. So as long as we are still in the procedure, the source database is there, it's up and running. There are no end users working on the system, of course, because they would need an application server for that. It's up and running, and so it's an easy fallback to return that. Once we have finished the productive migration, of course, we will shut down the source database as we want to free resources. That's clear, but it's an easy way to reset this. This is a matter of 20 or 30 minutes, and then the system is back at the point in time where we have entered the downtime. That's the advantage. Now, there are some use cases or specifics for DMO. Let's have a look at this. First slide out of two. This illustration says, well, we have a system with a primary application server. We used to call this essential instance. And we have the source database that we typically abbreviate as any DB. That means any DB, but not HANA database. And in this example, we want to migrate to HANA database, so any DB, the other one here. So DMO is the combination of migration and the update of the SAP software. Potentially for a target below 750 basis, the SAM1.1 even offers to execute the Unicode conversion. Typically, we extract and start the software update manager as a tool on the primary application server, and this application server is kept. That's why we call this procedure an in-place procedure. And the software update manager that is started on this host will start the kernel tools like R3 load on this same machine on that host. Then it is possible to run the software update manager on an additional application server as well. That is possible. There are some boundaries to be considered, but the benefit could be if you have an additional application server with more performance that you use this one to run more R3 load, for example, to speed up the procedure. So the benefit is to run the software update manager on the host with the best resources available in your landscape. Now, we started with the DMO option as a combined upgrade and database migration. Meanwhile, it's also possible to say, well, I do not need to update the SAP software of the ABAP stack. I want to use the migration only, and we call this DMO without update. That is possible as well for targeting HANA database, not for the other potential target database types. That was the first slide on the DMO use cases. The second slide now says for this plain DMO that I've explained, it is not supported to move beyond boundaries of a data center or even to a hyperscaler. That's why we came up with the approach that we call DMO with system move. This approach, as part of the software update manager, means we have a source landscape with application server and database, and we would like to move the system to a different data center where a new application server host and the target database is available. That's what we call DMO with system move. That's the use case where we move the complete system. So that one is no longer in place. As you see, we move the complete system. We do not only let the tool switch the database, but also the application server level is kept as switched. Sorry. So of course, we have to prepare the application server host in the target in this environment. And this is a scenario that allows you to switch the primary application server host if you would like to use the maintenance event to combine it with a new hardware appliance, or you can move across data center from one data center to a different one, or you may migrate to cloud in the sense of infrastructure as a service or to a hyperscaler. That's what we have with DMO with system move. The requirement is that for this scenario in the target, that of course the target HANA database on its host is prepared and the application server host with application server software is prepared. And this scenario is only supported for targeting SAP HANA or SAP ASE, not for the potential other target database types. The sequence is we start the software update manager in the source environment. We let the tool export all the content from the database. Then the subdirectory is copied to the target environment with all the dump files that are created in this case. And we start the software update manager on the target, and the tool will recognize, well, I've changed the environment. I'm in the target environment. So I will now import the data into the target database. That's the sequence. And this approach in general can be combined with DMO without software update. So if you your source ABAP stack is on a level sufficient, then you can use this. And you can even use this to run in the source, for example, the software update manager on an additional application server to have a better performance that can be combined. So these were the introduction slides on DMO, on the database migration. I just wanted to mention here the reason why we do not support the plain DMO for the data center move is that our research, our tests have indicated that there are potential latency issues. Nevertheless, meanwhile, we have started a pilot approach. You see this down below on the slide, and you can check this blog post that we have published if you would like to learn more. We are currently evaluating for conversion scenarios, so targeting SAP S/4HANA, to use the plain DMO, even for a scenario where we would like to move to a hyperscaler, like in the RISE context, where you may target the S/4HANA Cloud Private Edition. So read this blog post if this is relevant for you. That was part number one. Now, how does it work and how does it look like? Some details on the procedure are to be shown here. And of course, the prerequisite, as always for the software update manager, is that you have done the planning and the maintenance planner, at least for the major scenarios. So in the maintenance planner, you pick out your system and you start a maintenance event here. And that will allow you to download the software. And the specific thing for migration scenarios is that you will have to manually select the target kernel for your target database. So target database like SAP HANA, if your source is on MaxDB, in the maintenance planner, you will select the SAP HANA database with the respective kernel for the target release. Those have to be put into the download basket, and you will put this together with the stack XML, of course, into the download folder. So the software update manager will find those respective kernel archives to be applied for the target system then running then on HANA database. The other thing is that you need a migration key that is available in the SAP One Support Launchpad, like the maintenance planner as well. There's a migration key. You have to request the migration key that has to be provided in the user interface of the software update manager. These are the things you have to prepare specifically for migration scenarios. Then you usually, as usual, start the software update manager with a browser interface. Here you specify the location of the stack where also the software archives are located. And then the dialog will show you if your source database allows migration with a software update manager. It will show you as the second user interface, the second dialog, now the option to migrate. The default is no migration, and you will select the target database, in our case here, SAP HANA database. So the tool knows that it's not only an update, but it's also database migration to this target database. That is the very beginning of the scenario in the user interface of the software update manager. Now we will have a look at some architecture slides explaining the main steps of this approach. Let us first have a look what is illustrated here. We see down below in the left corner the source database where we have the repository, the ABAP repository, and the application data. Up above, we have the host of the primary application server. That is not a must, but this is illustrated here. And we have the productive instance, so the application server as an instance. And we have the software update manager here extracted from the archive. We start the software update manager, and the software update manager will create what we call as a shadow system. That is a general approach that the software update manager is doing. It's doing some steps already in uptime to reduce the downtime processing. That's not only the case for migration, it's also the case for update or upgrade. And the shadow system consists of a shadow instance and the target repository. So the ABAP repository of the target level that we are aiming here with this combined migration and update. So the target repository is created already on the target HANA database. You see this node. In previous times, this was different. I will not mention this. It's just that now the target repository is located on the target HANA database. And we have a shadow instance that's running in parallel to the productive instance here. The shadow instance is using the target kernel already because it has to fit to the target repository here. That's done in uptime, so the end users are still working on the system. The next step is then that the downtime happens. So we tell the software update manager to shut down the central instance here. And then this R3 load export import will happen. That means you configure in the SUM user interface how many R3 load processes you would like to use. So there are R3 load pairs running in parallel, several ones, 40, 100, or 500. And each pair is consisting of one R3 load that is exporting from the source database, passing to its colleague there that is then doing the import into the target database, concerning the application data here to the target environment. That is the migration of the application data. After that, the software update manager will start the ABAP instance just for finishing up the procedure. It's still downtime for the end users. And then the target kernel is used and the update procedure on the application data is done. And then finally, also the application data are on the target level. The procedure is finished and the system is running on the target database, for example, SAP HANA, and the application server is still the same. That's why we call this an in-place procedure. That is the plain DMO approach. Now, let's come to the section number 3, how to tune and to optimize the downtime. So aspects for technical downtime of the DMO procedure. We start with tuning and optimizing the downtime. So if we are talking about a database migration and the combined update of the SAP software, The downtime overall is dominated by the migration part. So migration of the application data from source to target database scales with the source database size. So the migration is the dominant part. The migration as such is influenced by, on the one hand, the number of R3 loads that you configure in the SUM user interface that are to be used in the downtime. There are some default values, but you will find your own values that can be quite high. So don't get scared to increase it above 100 or 500, depending on your capability of your host, of course. They all run on the same host on which we have started the software update manager. And of course, you need a good network bandwidth. So you need at least this 10 gigabits per second network card, and take care that there's no firewall blocking or shrinking down the bandwidth, the transfer rate of your procedure. The rule of thumb, based on all the experiences we have, is for a standard setup, for a typical setup, you should be able to reach a migration rate of, for example, 300 gigabyte per hour. So that is an indication if you start your first tests and you read the log files of the software update manager and you find, well, the tool tells me we have a migration rate of 40 gigabyte per hour, then you should consider there's something wrong. You have to tune the procedure or find out whether there's a firewall, for example. With this rough rule of thumb, you can estimate the overall runtime. Is to say the update part may take additional 8 hours. For example, then you can have a first very rough estimation on the downtime, which of course will be validated then with your test runs with the copies of the productive system there. So your task when you use the software update manager for database migration is you have to optimize the number of R3 loads. The table splitting is done by the tool. You have the task to find the best number of R3 loads. So you will have to iterate the procedure and find the best number of R3 loads. Again, there are default values by the tool. They are always the same. The tool will not consider any hardware that is available. Those are the default values, for example, 64. R3 load processes, and you will adapt this. That's very important. Don't take those numbers as granted. Now, the table split calculated by the software update manager is done automatically. And if the tool starts the first run, it will read the database statistics to find out which table has which size, and then to decide whether or not to split those tables into different chunks that can then be migrated in parallel. That's why we recommend you to keep the source database statistics up to date so that the database, so the data on which the software update manager is doing its calculation is up to date. Very important. You can optimize the table split calculation after you have done the first migration run of the software update manager by providing what we call duration files from a previous run. What does it mean? Well, I told you for the first run, the tool will determine the table sizes, will then do a migration, and the tool will write down which table took how long. So after your first migration run, the tool will put it into an XML file where all those tables beyond a specific threshold are listed down with their migration time. And the migration time is much more relevant than the table size for a table. So that's why if you have done a run, you take this file, you feed it back to the tool, you put it into the download basket, very easy. And then the tool will take the migration duration for each table as a better indication which tables to split. That's an easy procedure. Let us see what other possibilities we have to tune the procedure. There is not only the DMO option of the software update manager, but also the benchmarking. Benchmarking is an easy way to do a quick test. I told you per default, DMO is a combination of an upgrade with a database migration. So if you start this procedure, the tool will first set up what we call this shadow system. With the shadow instance and shadow repository. All this takes time. If you would like to tune the migration, you have to wait until those long-running phases, uptime phases, are finished. So instead, you can use the benchmarking to start with, because the benchmarking will only execute the migration for a test run. So you do not have to wait until this shadow system is being built up. That's very important. So let's have a short look onto the user interface of the software update manager. You know, the entry point is where you specify where's the stack XML located in the download folder where the archives are. But there are some scenarios that do not require a stack configuration file. And if you choose this one, you will find out that there is an option called benchmarking. And this will allow you to run only the migration, even with a small portion of the source database. So you can run the benchmarking to migrate data from your source to the target and say, well, I would like to migrate only 10% because I would like to get a first feeling. It's a quick procedure. That's the recommendation. And after that, you can do the real DMO run. So let's return here. That's the recommendation. And even for the benchmarking, you will then tune the number of R3 loads. You will see what the performance of your host is. And if it's running on low level, then you can increase the number of R3 loads until it reaches, let's say, 60 or 70% load the application server. And then you get a feeling how many R3 load processes you can do this. You will do this for the benchmarking run, and you will do the same for the proceeding full DMO procedure as such. And then we have something else for test runs. We call this test cycle option. That's a fast repetition. Let's have a look on this illustration. So this green bar is the uptime processing of the software update manager. There are some checks, there are some preparations, there's the setup of the shadow system, shadow repository, and then there's a point in time where the tool offers to enter the downtime. That's written in red here. And then there are some post activities here. So in all those phases here, you can use the reset function. I told you source database is kept, is still running. So you press the reset button and the software update manager will start from scratch. You can do this to repeat the migration part, but then you will start all over with all those phases setting up the shadow system. Instead, on a test system, in the downtime where the migration happens, there's the option to say, I would like to use the test cycle. What does it mean? The tool will execute the migration, will stop in downtime, and ask you, shall we do it again? That means at this point in time, the migration has happened. For example, those duration files with the migration timing per table have been created. The tool will automatically consider those timings and do the migration again. So that's what we call the test cycle. Excellent to tune and to repeat in a fast way without the need to let the tool set up all those phases in uptime that take long. So the test cycle option allows a fast repetition of only the downtime migration for a test run. Of course, you will never switch on this test cycle for your productive migration. You do not want a dialogue coming up in downtime saying, shall we do the migration again? That's clear, but of course, you know the point. I have talked about the migration files. You put those migration files from the previous run into the download folder, and the tool will then repeat the calculation of the table split to avoid a tail in migration that would extend the downtime. And that is a nice feature that can be used, was already mentioned. What else do we have? If those tunings turn out to be not sufficient, we have something we call downtime-optimized DMO. That's an advanced technology that is available for business suite systems, not for BW. For BW, there would be something like data cube cloning. And of course, we have an offering. We have the NCTT service-based approach. You can have a look at this SAP node. That is not a tool that you use. It's a service where experts from SAP will execute your migration. That's to be mentioned here as well. So the recommended procedure for tuning the standard DMO, apart from those extended procedures, the tuning here is you start with a benchmarking tool. You use an option that tells you export only. That means you will only export from the source database, but not yet import into the HANA database, just to see how the export works. And if there is a bottleneck, and this will even lock down in these log files of the software update manager, the database size that the tool recognizes, as not all content is exported. And then you can do the export and import of the benchmarking, shrinking it down to say, well, start with 10% of the source database. The tool will select appropriate tables to get a first impression on the migration rate. Then you already change the number of R3 loads to find an optimum. Use the test cycle, if you like, and then you do the real DMO procedure. You use the duration file from the benchmarking run. You again tune the procedure, where we have to say there's an important difference between benchmarking and the real DMO run. Benchmarking happens while the source system is still running. That means there are less resources on the application server since the kernel is still running, the application server is running. So benchmarking will not allow you to use as much R3 loads as the real DMO run, where in downtime, the ABAP system is not running. So that's why you will again tune the number of R3 loads to be used. And then you will find the optimum number, and the real complete procedure will be run with a fixed set of R3 loads. That's important. All this is explained in an excellent blog post that a colleague from the SAM development team has written a while ago. So that's why we have listed the link to this blog post as well. Again, I tell you, tuning is important. You change the number of R3 loads even during the procedure until you find the best number of R3 loads. And then you have one run with the fixed number of R3 loads, because the tool will calculate the table split based on this number. And so that should be the same number that is used for the migration then. How can you adapt the number of R3 loads in the user interface? Well, in the user interface, there's an entry called Sum Utilities here. If you open that, a new browser window will open, and there is the possibilities under some parameters to change the sum process parameters that you have entered in the beginning of the procedure. You can change this later on. And there is another entry in this Sum Utilities. That's what we call the Process Control Center, where there's a Charts Control Center. And there you see the number of R3 loads that were configured, how many are used. You even see the what we call buckets, so the work packages for those R3 loads. You can have a look at the log. And you can adapt the number of R3 loads here dynamically by either typing it in or by using this slider. That's what we recommend, to dynamically adapt the number of R3 loads in the phase where you are still looking for the optimum number. In parallel, you will have a look at the load and the performance of your application server host hardware. That's the adaptation. The next slide is now on the question of checking data. That is the topic table count and table comparison check. We have already seen the first dialog where you specify the stack XML. Then we have the second dialog where you decide to have a migration scenario. There's one dialog in between that I skip, and then there is the scenario strategy where you can decide whether to go for the standard approach that I'm focusing here, or on downtime optimized migration that will be shown on the next slide. And then, so the fifth dialog of the software update manager tells you we have the possibility to do a table comparison check and to switch off table count verification. That's the actual status. Previous releases of the software update manager with a lower SP number do not show this second option. What is it? Well, typically you would keep on the table count verification. So the tool will count the number of rows in a table before and after the migration. The other thing that is possible to switch on is the table comparison, where not only the number of rows, but the content is checked by the tool. That could be relevant for intermediate check there, but you should not turn this one on for the productive migration of your system, since this extends the downtime drastically. So you can use this as a kind of verification and test run, but you should not switch on the table comparison in the actual run of your productive system. These are the two parameters that are available. And finishing up here on this fifth, did I count right? Fifth dialog of the Software Update Manager. If we look down here, we see the migration repetition option for test runs that I mentioned. So in the downtime, the tool will stop and say, would you like to repeat the migration to tune the R3 loads? And the other one is DMO with System Move, offering the move of the system from one data center to a different one. That was already explained in the beginning. So 2 slides left. The one that I focus on now is downtime-optimized DMO. That was mentioned. So if you tune your procedure, you find the best number of R3 loads, you have done archiving on your source database to reduce the database size, you still find out downtime is too long, then you may consider to use downtime-optimized DMO. That's also known as Uptime Migration. It's a technology built into the Software Update Manager. It's available since quite a while. It can be used for migrations and also for system conversions to SAP S/4HANA. First, let's have a look at this illustration. The uptime processing of the tool is quite long, longer than shown here. That is the time where also the shadow system is being built up. Then we have the ramp down. And during the technical some downtime, we have the migration part and the update part here and post activities. Now, uptime migration means we select large application tables that should already be migrated in uptime to reduce the downtime. So it's a manual process. You manually detect what are the large application tables, and there is support from our side to identify those that are suitable to be migrated in uptime. That's the good part. So uptime migration is possible for selected large application tables. And if we say uptime, that means end users are working on the system. So how about those changes on tables that have already been migrated? Well, it's reflected by the Software Update Manager. It has its own technology to replay those changes by the end users. And this is done by an initial and a data migration and uptime, and the remaining delta is migrated in the downtime. So that's an option. The option as such is offered in the SAM dialog that was nearly visible on the previous slide. There is a report that we offer to select the appropriate tables for uptime migration. There is a replication monitor that shows you the number of changes that have been replicated by the tool with its own technology. And this of course, only offered if the source is not yet HANA database. So downtime-optimized DMO works for targeting HANA database, and the source has to be not HANA. Otherwise, we would not have a migration case. That's clear. With this, let us finish with the overview on the information sources. I guess the general recommendation is to use the support portal quick link /SL toolset. That's the landing page where all the relevant SAP notes, the guides, the blog posts, and detail pages are listed. So you see the SAP notes here for DMO with SAM 1.1, the DMO with SAM 2.0. All those notes are always up to date on this landing page. That's why the central information here is you should know this /SL toolset as the landing page in the SAP support portal. That was our session today. And now let's have a look if you have put questions in the chat.
Thank you, Boris. Thank you for your presentation. And I will upload the presentation to the description of this video. So please feel free to check the replay if you would like to leverage the materials of Boris' session. And yes, we have 2 questions in the chat, and I will start with the first one. How to estimate some folder size in DMO with system move scenario during planning phase?
Okay, thank you for the question. Let me put this into the broader context. So for the plain DMO, the standard DMO, the tool is using those R3 load pairs, so there are no dump files. But there is an exceptional case. DMO with system move allows to move the complete system. And that means we start the software update manager in the source, where the tool is exporting the data into the SAM folder. And then you copy this up to the target. And so you need to know what will be the expected size of the SAM folder with all the database content is stored in there. There is an easy rule of thumb, very rough estimation is those dump files are compressed by a factor of, let's say, 10. So you can estimate based on the database size, or better, on the database size that the tool reports in the log files, as this is the relevant part that will be stored on those files. And those dump files are compressed. And this is a rough factor of 10. That would be my answer to this good question.
Thank you. And we continue with the same author. If the OS of the source in brackets window and the target in brackets RHEL, PAS hosts are different, which DMO method will be feasible?
Okay, so I understand the question is that we again have this DMO with system move. We have a source system with database and application server on one operating system, and we would like to move this to a different data center or hyperscaler. And now on the target, the operating system may be different. That's how I understand the question. And now this DMO with system move is existing for both SAM 1.1 and SAM 2.0. It depends on which of those two are used, since SAM 2.0 allows to even have deviating operating systems. So that would even be possible to say we have Windows in the source and Linux in the target. That would even be possible with DMO with system move. So that should not be a barrier, at least if you use SAM 2.0, which depends, of course, on your scenario on the target level. The more detailed answer is for DMO with system move. We have quite advanced technologies to even automate the transfer of the data from source to target. And this will maybe have to be adapted if you have different operating systems. So just to elaborate a bit on this, DMO system move source environment, target environment, let's say both is Linux, then you can set up an SSH connection between the two hosts, and you can tell the software update manager on the source what the target host name is, and then the software update manager will start an internal script that will trigger our sync. When that will synchronize the two SUM directories. We call this the parallel mode. And this may not work in all combinations of the operating system. So I hope this was an appropriate answer to this question. Otherwise, feel free to ask again in the chat. Thank you.
Yeah, thank you, Boris. And we continue. For DMO with system move with different OS of source and target, the upgrade media to be downloaded for target OS in brackets kernel, even though some will be started in source system.
Yeah, Good point. So again, DMO with system move, we have one software update manager in the source and we copy it to the target. The trick is the tool, meanwhile, creates the shadow repository and the shadow instance on the target environment. So if you have DMO with system move in the source environment where you start the tool, you decide DMO with system move, the software update manager will not ask you anything about the HANA database because in the source there is no HANA database. And that means you will have to put the download folder with all the archives for the source application server and the target application server. And once you start the software update manager in the target, it looks for the download folder and then it will use those kernel archives for the target operating system and target database level. Target SAP level. So the answer is you need to provide the kernel files for the target operating system and the target software level, of course. Yeah, good point.
Thank you very much. The next question is, any plans to introduce a hands-on SAM DMO course in SAP Learning Hub?
Okay, concerning education, we have an education offering that is HA250, HA250. That's a 2 days training class, which with hands-on experiences offered by education as a classroom training or virtual classroom training. As far as I know, there's no plan to have additional or the same offerings in the SAP Learning Hub with hands-on experience. There was an offering by the regional implementation group, an open SAP training concentrating on system conversion. So that's a broader scope. And there it was possible to use a CAL image, a Cloud Appliance Library system, to work on the conversion that included the migration as well. These are the things that I have currently in mind concerning education. For Learning Hub, I'm not aware of any plans.
Okay, thank you very much. However, there are options around education, and maybe if you can place the name of the course in the chat, so I can also share it with the community.
Yeah,
this
I will put this in our chat. Mm-hmm.
Yes, and I continue with the next question. Is there a limit for number of some processes like R3 load, R3 trans to be used?
Yeah, good point. So you start the software update manager. There's a dialog where the tool asks you for the number of R3 trans and R3 load. For R3 load, there is the maximum number of 1,000 that can't be exceeded. And our experience is there was never a project that needed more than 1,000. But again, let me emphasize, don't be afraid of big numbers, 500, 800. We have seen a lot of projects with those numbers. The R3 trans, as far as I remember, the suggestion by the tool is pretty good. I'm not aware of a real limit from the tool side, but if you have too high numbers, the performance may go down of the respective phases. Thank you.
Thank you very much. I can't see more questions in the chat, but maybe after this expert conversation, there will be some more questions coming up, and I hope the answers were sufficient. So it would be great to have a short feedback from the audience, whether the answers were sufficient. Otherwise, please, we have a few more minutes left. Please think of the question and state them via the chat. I've also added the number of the course on recommended by Boris in the chat. In case you are interested, please take advantage of this information. So I can see, thanks a lot for clarifying. It was a great session. This compliment goes directly to Boris.
Thank you.
This is very nice to hear. And I can't see additional questions in the chat. Again, as I've already indicated, I will add the slide deck of Boris to the description of this video. So, the materials will be available for on-demand consumption. With this, thank you very much to the audience for being attentive listeners and asking the questions. And of course, thank you very much to Boris for sharing your knowledge. And we are looking forward to the next session with Boris that will take place next week on 20th of September. And the topic of this session was mentioned also in the materials of this session. I think it was there on the second slide. With this, thank you very much. Again, look forward to welcome you in one of our upcoming sessions. Have a great day and bye-bye.
Thank you. Bye.